Hello everyone. So today we're going to be continuing talking about transformations, and for this one we're going to be learning about reflections. So a reflection is just a transformation that uses a line like a mirror to reflect a figure. So just like when we look in the mirror, that's really our reflection. We're going to be doing the same type of thing, but with figures on a coordinate plane. We're going to reflect them across a line. And that mirror line is called the line of reflection. So a reflection on line M was going to map every point P to point P prime, so that for each point one of the following properties is true. If P is not on M, then M is the perpendicular bisector of the line P prime. And if P is on M, then P is equal to a P prime. And this one is also rigid motion. Remember we talked about rigid motion. That means that the figure does not change shape or size. A reflection is another rigid motion. And so that means that these are also congruent transformations. And everything that's being said right here, basically what that means is if I have a point P and I reflect it over the line, the distance from point P to that line of reflection will be the same distance that P prime is to that line of reflection. So they're congruent. And so in other words, let's say if the distance from P to line M was 2, then the distance from P prime to line M will also be 2. So they are the same distance away. And this will actually be the shortest distance. So the shortest distance from a point to a line would be this perpendicular bisector. And then a fun case that we can kind of get, or an interesting case, is if P is actually on the line of reflection, then P prime is going to be the same. And that's because they're both going to be 0 away from the line, since they're actually on it. So if the point is on the line of reflection, when you reflect it, it's still just going to be the same point. And so we have some reflection coordinate rules. There's going to be 6 different types of reflections that we'll see for this section. The first one is a reflection in the x-axis. And that rule that we have is that xy is going to be mapped to x negative y. So for this point I have 4, 3. If I reflect that point across the x-axis, my x stays the same, and then I take the opposite sign of y, so I have negative 3. And so I see that point reflected will be down here. And you'll notice that A is 3 units away from the line of reflection, and A prime is also 3 units away. So I see it's reflected, just like looking in a mirror. Now, if I'm reflecting across the y-axis, I'm going to change what I take the opposite sign of. So for this point, I have negative 3, negative 2. And then now when I reflect that, I'm going to take the opposite sign of x. So since this one was negative, now it becomes positive. And then y stays the same. And so I see that 3, negative 2 will be right here. And so you can kind of think of it, if I were to fold that, my points would be in the very same spot. I am reflecting it. Or if you remember, maybe in elementary school you put paint on a piece of paper and you folded it in half and then opened it back up and you got a symmetric figure. This is kind of the same thing. Okay, and then I have, if I'm reflecting across x equals some number, so for this example it's x equals 2, there's not actually going to be a rule for that. So for that one you're going to have to look at the picture. So for here I see that A is 3 away from my line of reflection. So to map out my A prime, I'm going to have to go 3 away as well. So 1, 2, 3 away. Then we can also reflect across the line y equals x, and to do that I'm just going to take my coordinates and I'm going to flop them around. So here I have the coordinate negative 3, 2. So when I reflect across the line y equals x, I'm going to switch my x and y coordinates. So now 2 is going to be first, and -3 is going to be second. And so when I plot that, I see that is right there. Okay, and then for y equals -x, we're going to do the opposite of that. So now I'm going to flip my coordinates, but I'm also going to take the opposite sign. So here I have the point 4, 1. When I reflect across the line y equals -x, I'm going to swap my 4 and 1, so I have 1 and 4, but I'm also going to take the opposite sign. So these are both going to become negative. And there's the point there. And then when I have y equals a number, again, no rule. So here I have y equals -2. And so to reflect this one, I'm just going to see how many spaces away I am from that line. So here I see that I am 4 away. So now I'm going to have to go 4 away on the opposite side. So 1, 2, 3, 4. And going back to the Mona Lisa, I can see how the reflections affect her. So here I see the reflection across the x-axis. I see basically it turned her upside down. If I am reflecting across the y-axis, I see that these reversed here. So they're still up and down, but now she's looking to the right instead of looking to the left. And I see if I reflect across the line y equals x, it just kind of switched her around there. And then y equals -x. And so reflections do change their orientation in that way. Okay, that's it for this video. You can go ahead and move on to the next one.